Welcome everybody to a joint NYTECH and computer science PhD program. I'm very happy to have an opportunity to have Peter Bell come. He's an evangelist for Hack New York. I keep saying NYTECH. Hack New York. He's also an evangelist for NYTECH in the future. We'll get him to do that as well. So his talk is about the what's happening in the database world beyond SQL. So we're very interested in hearing what you have to say.
Thank you very much. Thanks everyone for coming out. So, trends in database technologies. What I want to be looking at is, we've all presumably got experience. Firstly, just to get an idea, who here is a student or graduate student? And who here is from the NYTECH side of the house? Okay, gives me an idea. Fine. So we've all presumably had decent experience working with SQL, with Oracle, MySQL, Postgres, whatever it is. Obviously, over the last few years, there's been this huge kind of tsunami of new database technologies. There were always database technologies out there that didn't rely on structured query language, that weren't relational databases, but really they've only become broadly popularized in the last couple of years. And what I want to start doing is taking a little bit of time to talk about where we're from, which is the relational SQL world, at least for the last 20 years or so, where we are now, which is all of the popular NoSQL data stores, and some of the places we might be going, talking about things like Rich Hickey's DeTomic, which is an immutable data store, a database you can't change. Or NuoDB, which actually kind of brings it full circle and says, you know what, maybe relational databases can be cool and scale. And so I'm going to talk just a little bit about these different technologies to give a kind of overview of the landscape. Just to give a very brief background about myself. So I am, as Ted says, an evangelist and hacker for HackNY. So I work with Hack New York to both evangelize the program with startups and with college students, and also to actually, I get to write code again, which is nice. So I'm actually building a couple of applications at the moment in Ruby on Rails, which is great because I'm a recovering CTO. For example, my last job, I was running the engineering team at General Assembly. And certainly in the time I was there, the only time I ever actually got to write code was as part of a presentation when it was on a slide. Unfortunately, I was a little too busy doing product and hiring and process and all those kinds of things to actually write code, so that's a nice change. And I also co-founded something called CTO School, which is a meetup for technologists who want to take their career to the next level. They know how to program, but what else do they need to learn to be a technical co-founder or an early stage CTO in a seed stage company? So to give a brief overview, what are we going to be talking about? First, the fact that SQL is actually pretty good. You sometimes forget how cool it is. I was very involved with the whole domain-specific modeling world, and actually I ended up using SQL as a really good example of a domain-specific language because it actually allows you to express a huge amount of intent very quickly. We're then going to look at the kind of rise of the aggregate store, whether it be key value stores or especially like the Mongos and Couches and Cassandras. And then Neo4j, the rise of the graph. It's a really interesting, different way of thinking about persistence. Most of us probably have some kind of background with graph theory, but it's interesting to see this being popularized with practitioners. And then DeTomic, the immutable data store, and NuoDB bringing SQL back. So these are the things that I'll be looking to cover over about the next hour. Maybe just a little less, there'll be a little time for questions afterwards. Although if you have any compelling questions and you want to jump out and ask them, feel free. But first, I'm being paid to be here by HackNY, so just a very brief word from our sponsors. And some of this will be preaching to the choir, but some of this was also put together for a talk in Stanford University, which was actually a little interesting, trying to say, oh, you know what you should really do is, once you graduate from Stanford, you should come to New York, because there's no interesting tech jobs out west. But basically the story, and I still stand by this, I actually have a couple of friends who've actually, after a lot of discussions, have decided to move their tech startups from Silicon Valley to New York City, including Pave.com, really interesting startup. And the basic pitch is, sure, there are some cool companies out west and there's some interesting things you can do with software there. But recently, there's been a lot of very, very interesting tech startups in New York City. I first came to New York in 2000 when I sold my .com to a business in New York from Houston, Texas, just before the whole kind of crash and then the quiet years for the startup scene in New York. But then ever since about 2008, that's really started to come back. I think for me, the break point was the great thing about the financial crisis and the kind of fall from grace of Wall Street is it finally became that point where people actually working at JP Morgan or Goldman Sachs would probably say, if they were asked at a dinner party, oh, what do you do? Would probably say something like, I club baby seals to death for a living. Because then at least they wouldn't have to admit to working in finance. So given that, that kind of freed up an awful lot of talent to work in the startup space, even though maybe we couldn't necessarily pay the same salaries that the big Wall Street banks could. And there's been a huge amount of things going on. I love the New York Tech Meetup Made in New York list. And there are hundreds of companies there that are starting in the city. And there's things like the regular New York Tech Meetups. And there's also hundreds of technology-specific meetups in the city. If for any reason any of you don't go to those, check it out. Just go to meetup.com and type in some technologies you think might be cool and turn up to some. Something I try to do is go to one meetup I would never expect to go to every month. Whether it's PhoneGap for the mobile side or whether it's something very specific about front-end design, it's amazing what you learn when you spend just a little bit of your time interacting with communities you usually wouldn't come across. And so some part of building this community then is Hack New York, which basically does HackNY does two things. There's hackathons and a summer fellow program. The hackathons are twice a year in the spring and the fall. We just had one at Columbia, April 6th, 7th. And then the fellowship program is trying to connect students with opportunities at local startups, especially the startups that just wouldn't be big enough to do a college recruiting tour. So it's to give them a chance to get a summer internship, but it's also a full fellows program. So what we do over the summer with them is sure that they're at the startups, but in addition, they get to have evening lectures and presentations from technologists and CEOs of tech startups. So it's a really well-rounded program, and all the students stay together in shared housing, so they get to learn what it's like at 30 different New York startups, not just one. So we're always looking for companies to sponsor and for students to be involved. We've filled the class for this year, but if anyone's interested for future years, please feel free to reach out either afterwards or by email. And the hackathons are great. This was one quick example of something that was done at one of the kind of 48-hour hackathons. This guy actually built something. This is a Columbia student that would allow you to, based upon your current location, you would log in with your Foursquare information and your Twitter information, and it would actually tell you in what direction your friends were checking in from at the moment. So it kind of had the lights going around the paper plate, and you could actually see, theoretically, you could kind of directionally follow those lights to figure out where all your friends were in town. I'm not sure how ready it is for productization, but it was certainly a fun thing to build over a weekend. So that's HackNY, and this is the application for the annual thing. So I would definitely recommend checking that out and let me know if you have any questions about it. And now, after the word from our sponsors, let's actually talk about databases. As we said, a number of things we want to cover. So let's start with the idea that SQL is actually pretty cool. And actually, I said that I realized this when I was giving presentations on domain-specific modeling and domain-specific languages, and that was the first time that I realized how cool SQL was. I think the second time I realized how cool it was when I noticed I didn't have joins using MongoDB, and suddenly found that there were certain things that I'd kind of taken for granted with other data stores that just weren't available. I mean, imagine if you were writing in your own favorite language and you didn't have a relational store. How much code would it take to implement to express this intent? Let's say that we have an array of hashes or dictionaries or whatever you call them in your favorite language, but an array of these hashes. And what I want to do is go through each one of those arrays. I only want to find the elements where one of the keys has a certain string value, where the city is New York. And then for each one of those that matches, I only want to take out a couple of the keys, the title and the start time. And then once I've got all these into the new array, which is presumably my record set, my result set, I'm then going to have to run some kind of sorting algorithm to be able to sort by, and actually it's a field I didn't even remember to put in there. So I need to add this extra key, sort by it, remove that key, and then return the results. I don't know about you. I mean, I gave a talk talking about this to a bunch of Java developers, and I was thinking, in Java, this would probably be 200 lines of code. Maybe 30 lines of code in Ruby, probably one really, really long line of code in Perl. But it's certainly a lot more work and a lot less clear in terms of expressing the intent that, hey, I just want to get the title and start time for the events that are happening in New York City, and I want to see the most recent ones first. So SQL is a pretty cool thing to have, but unfortunately there are limitations. I don't know if anyone here has ever had the pleasure of trying to scale a relational database across multiple nodes. So when you actually need to connect it and have it running on multiple computers, whether it's in master-master or master-slave mode. But it's generally, when I ask a room full of developers, there'll be like 100 developers, 3 hands will go up that they've done it. No hands will go up that they would ever want to do it again in their lives, because it's not that much fun. So there are problems with scaling to multiple nodes, not just in terms of administration, but also often in terms of performance, especially if you are trying to create some kind of master-master set where you always want to make sure that you have the very latest data. It's very easy to get into performance troubles because every node needs to speak to every other node before it can tell you, oh yeah, nobody else has updated that, we can now run your transaction. So then we got this whole kind of NoSQL explosion. And obviously before people were talking about this, there were XML data stores and there were object databases. There were all these other things that really never caught the broad public attention. But NoSQL is kind of the big movement that's encapsulating this idea that why do we only have these 2 options? Either we log stuff to a file, or we need to have all of the power of an ACID-compliant transactional relational database system. Sometimes the data is a little more important. I want it to be easier to access than something that's just stuck in a log file. But I don't necessarily always need full transactional capabilities for every other thing that I persist. So why don't we have some options in the middle? And indeed, NoSQL, it's not about kill SQL or the end of Oracle, much as that might be a nice good thing in some worlds. It's the idea of not only SQL, not limiting ourselves to only relational databases. The problem comes when you try to describe this. This is effectively describing a negative space, right? It's any database that is not using structured query language, that's not using kind of Cobb-style relational algebra. The problem with describing a space by the negative, I was trying to find a way to kind of explain the challenge, and it would be like if I said, there's this great new type of car called a no Toyota. It's a vehicle that is not made by the Toyota manufacturing company. So you'd probably ask me, well, can you tell me some things about it? I'd probably have to give you some examples. So I'd say, well, let's see, Ford and GM would be examples of no Toyotas, right? They're vehicles and they're not made by Toyota. So what would I say? Like mid-sized family sedans and trucks would probably be the way to think about NoSQL data stores, or think about no Toyota vehicles. But then I'd be like, but then of course there's always stuff like, there's Lotus and MG. So there's like the mid-American vehicles and little fast British sports cars. Okay, so there's kind of these 2 types of no Toyota vehicle. Or an annoying Italian vehicle, like a Fiat. So so what can well, there's one thing I can definitively say. There's one thing I can definitively say is a parameter of a no Toyota vehicle. It's definitely not made in Japan. Except, of course, for Suzukis, which are non-Toyotas that are made in Japan. And you kind of run into this exact same thing, because one of the things people will talk about is, NoSQL data stores don't provide atomic, consistent, isolated, durable transactional capabilities. Neo4j does. It's a graph database that is definitely not a relational data store, but it does provide atomic transactions. So the question is, how do you think about this space? And often I find a useful way, now nothing actually sits and fits completely in these categories, but a good way of starting to think about it is in these 4 broad areas. And this is a good way of when you first see a NoSQL data store, you can say, so is it key value, graph, big table, or a document store? Increasingly, I'm seeing that the line between key value and almost everything else blurring, because the people in the key value space are like, man, if we just added this extra indexing capability, we could become this, or we could become that. So it's starting to blur, but it's still a good first approximation when you're trying to think about the kinds of use cases. Why would you actually use these different types of store? So first, let's talk about the kind of left and bottom 3, because these are all can kind of be thought of in some ways as aggregate stores. Now, in the simplest kind of an aggregate store, you generally don't have, and again, this is starting to change, but you generally don't have visibility into the aggregate. So you're storing blocks of stuff, and generally you can't filter or search, except maybe full text search, on the contents within it. So the traditional use case for key value stores was when you needed to scale something, but you really didn't need to report or query on it. Redis is an example. So for example, if I'm Amazon.com and I want to store your shopping cart, I don't want to store it client-side. I actually want to have it on the server so that if you log in again some other time, you'll be able to get at it. Now, while it might be interesting to run analytics on what books are or are not in shopping carts and what percentage were abandoned and stuff like that, that's not really my core use case. My core use case is the next time you log into the site, I need to look up your user ID, go get the shopping cart with that user ID and return it to you. And that's it. So there's the key, which has some kind of value that I really don't care about, just so as it's whatever you put into it the last time you were shopping. So the great thing with key value stores is because they're technically very simple in a lot of ways, they're generally designed to be incredibly easy to scale to multiple nodes. Often what I see companies will do, where this isn't a greenfield environment, often the use case is taking load from a relational database server. So what happens is you've got this Oracle server or this MySQL or Postgres server that's creaking. It's running at like 80%, and it's getting to that point where soon you're going to have to set up master-slave replication or master-master across two nodes, and life's going to get very difficult. Instead, what you can do is you can say, you know, of all this stuff we're storing there, how much of that actually needs transactional capabilities? Often you find it's maybe 30, 20, 10% of your queries, and you can offload a substantial chunk of the other things you're doing, like storing shopping carts, or maybe even product information if it's an e-commerce store, and you can throw that into Redis or some kind of other key value store, and now you've got the load down to running at 20 or 30%, so you can now scale your business substantially without having to deal with scaling the relational database. The kind of big table column-oriented databases, probably the most popular, there's lots and lots of key value stores. The most popular big table or key value store, big table or column store would probably be Cassandra. And generally I find the use case for this is very, very specific, and it's often around linear write scalability. I can write a certain quantity of data to a single node, and I need to write 20 times that quantity. And I'd like to only have to buy 23 or 24 nodes to get that scalability. Because generally the problem you're dealing with is chatter between nodes, right? Oh, I want to save something to this node, and this node has to figure out what other node to actually store it on and then punt it over there. Or this node has to speak to the other nodes to see if somebody else has updated it or not. So it needs to have all that chatter, which means that when you want to double the amount of write volume you can handle in excess of what a single node can do, you might need 5 or 6 nodes because of all the extra overhead with them chatting to each other. The way that Cassandra and most of these kinds of solutions store this is using multi-version concurrency control, where it's kind of saying, well, you want to write something, you can just write it. And we'll stick some kind of universal timestamp on it. We won't worry about incrementing counters. We'll just use globally unique identifiers, and we'll figure it out after the fact. You know, if there happen to be conflicts, if 2 people have edited the same thing, we'll deal with that later. For now, we're just going to capture your writes. And generally, the use case is for things like logging large quantities of data. You also find Cassandra sitting like behind Hadoop clusters and things like that in the big data world. And as a good rule of thumb, if you don't need Cassandra, you probably don't want to use Cassandra. It is not the easiest system to set up and configure. I mean, I was talking with a friend, and he's like, you know, after the first week and a half, you really actually figure out how to get it installed and running. And I'm like, yeah, most of the other data stores, it's like after the first 20 minutes, you've figured out how to get it installed and running so you can actually focus on doing something with it. So you definitely want to have somebody with some experience before you go in that direction. Then we've got the whole world of document databases. So CouchDB is an example. MongoDB is the hometown example, 10gen out of New York. And they actually solve fairly distinct use cases. Couch, I think, is a really good mobile and disconnected story. It's got a lot of mobile clients. It's a great solution. If you wanted to rebuild Lotus Notes for the 21st century, you'd probably do it using CouchDB. It's got really good semantics for, it supports multi-version concurrency control. So you can have your disconnected node where you do stuff, you can connect it to the other nodes, and then it will kind of it makes it easy for you to create business rules to figure out how to resolve all of those conflicts. So generally, it's good for that. Mongo's pretty much good for almost anything else. MongoDB is a great data store because what it allows you to do is get very, very performant queries. And it also allows you to aggregate information effectively. So potentially, it can be very simple to return if you want to display a recipe. And that pulls information from your ingredients table and from your steps table for the steps in the recipe and from your photos table with the URLs of the photographs. Instead of having this kind of all of these joins together, you can actually just have a recipe object, which is comprised of a number of keys and values that can have embedded keys and values. And you can also do really nice things like if you're working in a relational database and you want to do tagging, you want to say, hey, I've got these posts and these comments, and I want to tag them with keywords. Typically, you'd have a posts table, a tags table, and a many-to-many join table to join posts to tags. Well, with Mongo, you can actually just have a field in the posts in any given post called tags. And you can put a comma-delimited list of the tags there, and you can still index that just as performantly, probably more performantly than if you had a join table. So it actually allows you to do indexes on, even if you have, say, a company that has number of addresses, you can do indexes on the city so that you can very performantly find all of the companies in a given city, even though it's the kind of thing that if you were persisting that in a relational database and you were embedding it in the same table, it would be much, much harder. So MongoDB is a great solution to the extent that I know some companies in town that build everything using Mongo. They're building startups and they just use Mongo for all of the applications they build. But there are some issues you need to be concerned with or be aware of. The main thing, there's two places I think I see people getting into trouble. One is not understanding the way that, and I have like whole talks and whole presentations just on MongoDB, but is not understanding how Mongo works, because there's little things in the description of any given technology that you kind of just gloss over. Atomic document writes. Okay, so it just writes documents as one thing. Doesn't sound like a big deal. But it reminds me of a friend who decided that Mongo only works in the morning. So what was this about? Well, he was explaining to me the strange problem where he was using Mongo for analytics, which is often one of the good use cases because it's got very performant writes. And you can even set it to do fire and forget writes. So you tell it, save this, but don't bother telling me if you have or haven't. Well, usually, if you're doing bank transactions, that might not be a great idea. But let's say that you're logging 1 million records to disk every day. Does it really matter if it's 1 million or 1,000,003? If an occasional one gets lost in the ether? Probably doesn't. So for certain use cases, especially kind of broad analytics trends logging, that's one of the use cases for Mongo. Problem is what he'd done is he decided to create a log file per day. And so the way it works, and he was only logging small amounts of information, maybe 50 bytes every time one of his devices kind of connected back to the home system. Problem is, so first write in the morning, it's easy, 50 bytes to a document. Second write's not too bad, it read the 50-byte document, appended 50 bytes, and wrote 100 bytes. I think you see where this is going. So we get to like the middle of the afternoon, and it's having to read and write 12 or 13 megabytes of data to persist the 50 bytes. Unsurprisingly, the performance was a little less than stellar by that point. Now, there are lots of ways that you can do a really good job of persisting analytics in Mongo. It's used for that quite broadly, but you just can't do it that way. So you need to understand the data modeling. The other thing people say about Mongo, and it's interesting because on the one hand, it's schemaless, which means you don't have to say, I want to, if I've got a collection of user documents, you don't have to say, I want to add a social security number field. You want a social security number field, you just create it for one of those user documents, and it's there. So there's no schema migrations, which is good. But the bad news is you actually need to have a reasonable understanding of your read and write patterns before you decide how you're going to store things in Mongo. Let me give an example. Let's say that I've got a blog post and I'm going to have a collection, like a table, with all of my comments in. And I'm like, okay, so let's say that I'm trying to display that information. So I might get the blog post, and I'm going to go get all the comments for that blog post. Let's say they're in a separate document, so there's one document per comment. But then here's the challenge. At first I'm like, what should I do? I also want to display the user's information, but I can't really join comments to like the user's table or to the user's series of documents. So what am I going to do? Well, I'm just going to embed the user's name. Seems reasonable. Users don't change their name very often. So what I'm going to do is within the comments, I'm going to embed the names of the users who made the comment. And that's an absolutely fine decision. And it makes the performance better. It makes perfect sense. Denormalizing is often something you go to fairly early in Mongo, or a lot of people end up doing that. Then your boss comes in and says, so you know what, I decided rather than just displaying the name, I'd also like to display the number of comments that a person has made right next to that in the comment. Now what looked like a plausible denormalization strategy with one really fairly tiny tweak to the features, right? I mean, there's nobody who would say that's a huge change to the system. We're just, you know, in addition to your name, there's a little comment with the number of comments you've made, a little bracket. But now we would have to be looking for every time you wrote a comment, we'd have to look for every comment that you'd made and update that count. So now we're actually going to have to change our code somewhat substantially just because of that one small change in requirements. So Mongo is an awesome system, but you really need to take the time to understand how to do data modeling right. And I'd thoroughly recommend things like there's a Mongo NYC conference coming up in June. And if you use it, don't use it without learning how to do it right. So we talked about kind of a number of different aggregate stores here. But what I'd like to talk about is perhaps what seems to me like the next generation. And I want to give some examples. Most of you have probably heard about the whole, you know, Facebook graph search thing. So that now you can type in graph-like searches to find friends who like similar foods to you that happen to be in a certain country or town right now. And Google, as they acquired a company, and they've been doing something similar under the hood with their knowledge graph, which is designed to provide more context between pieces of information so that it can more easily move you to things that you might be interested in, even though they may not have a traditional text-based matching relationship. So they've got this idea of, you know, the Mona Lisa was created by Da Vinci, and this idea of connecting facts in a graph-based way. And even Twitter, if you actually look internally, they actually use, for most of their system, they don't, but they actually use a graph as a bottom layer of the stack to power things like who to follow and similar to functions. So they have their own graph technology running there. Well, for companies that are a little smaller than those, you probably can't just build your own graph technology. So I've looked at a bunch. The one that I'm usually find myself talking about is Neo4j. It's literally a jar file. So for anyone who uses Java, it kind of just drops right into your application. But I do a lot of Rails and Python work as well. And if you're not running on the JVM, if you're not running JRuby or something like that, then you can just simply stand up a RESTful server and talk to it over the API. So it's available from any programming language. So what are the use cases? When I first came across graph databases, I thought, well, it's all about social networking, right? In this case, the only downside I will say with Neo4j is that they started off by doing all these example slides that were using the matrix. And then they hired a couple of great technologists, Ian Thompson and Jim Weber out of the UK from ThoughtWorks, who are Doctor Who fans. So the bottom line is you've got to have substantial appetite for or patience for science fiction. But as long as you can put up with the sci-fi, it's actually a pretty good database engine. Okay, that explains. So I might expect, so there'd be like a social network with who knows who and who likes who and who follows who. That's an obvious kind of use case for a graph. It also fits really well for things like recommendation engine. Somebody who's a friend of somebody else and they both like certain types of food in certain types of location for doing recommendations. Max de Grazi, who's joined Neotechnology, the company behind this, maybe 6 months or a year ago, just recently wrote a really nice blog post showing how you can actually implement recommendation engines using the Cypher query language, which I'm not going to have time to get into it in this deck, but basically it's like SQL for graphs. You do this kind of weird ASCII art stuff that describes, I'm looking for these things that are related to these, only so many jumps away. And it's a fairly concise way for describing declaratively the kinds of queries you want to run on a graph. So I checked that out. But there's actually a much wider range of use cases than at least I initially thought. I remember I first came across the whole idea of graph databases and their popularization a few years ago. I was at a Groovy and Grails conference called the Great Conference in Copenhagen. And this kind of skinny Swedish guy who just jumped on the train from Malmo, because it was in Copenhagen, and basically Malmo in southern Sweden's about a 20-minute, 30-minute train ride. So he just popped over to see what all this Groovy Grails stuff was about. And so we end up going for a drink after the conference, and he starts to tell me about how, the end of the relational database is nigh. He's like, Oracle, all of this stuff will not be here in 10 years. I think he's still got 6 years to go, so I'm rooting for him. And it was interesting, he was like, even to the extent, he says, I'm not even willing to call what they do relational database. Why? Because there's only one relationship type and you can't even add properties to it. So he actually calls them square databases, because he doesn't think they actually do a very good job of implementing relations at all, as opposed to something like this, where you can have named, thoughtful relationships, you can add properties to the relationships, you can actually do a lot more in terms of relating your nodes. But there really are a wide range of use cases, things like e-commerce, because I have an address within a country, and an order has a shipping and billing address, and a customer has an address, and you can kind of relate all of these elements. Even content management is actually kind of a surprising use case for graphs. But if you think about it, okay, I've got articles, and a comment was added to an article. It was written by a commenter. And you can actually start to get some really interesting things out of this, because now you can start running analytics on the relationship between maybe people who comment and follow authors, and the relationship between commenting and following, and perhaps recommending people if you have friends on the service that you might be interested in. You can actually get some interesting information even in a content-based application. So the structure of it's pretty straightforward. A graph database, or specifically with Neo4j, it's built up of nodes and edges, or let's call them relationships, because that's what we'll usually call them informally. And any one of them, it's schemaless, so like Mongo or like, I guess, key value stores, you can kind of stick anything anywhere you want. Currently, I was speaking with Emil and a couple of the other people at Neo Technologies a couple of weeks ago when I was doing some GitHub training in San Francisco, and they're actually considering building a type system in. But right at the moment, the fact there's no distinction between, say, if you have users and you have products and you have categories, that's just your mental model of it. And you might maybe decide to have a key called type and create values called user or category or product. But there's none of that built into the system at all. So if you wanted to give a price for a user or a last name for a product, it would not complain at all. And basically, each one of the nodes and each one of the relationships is just an arbitrary collection of 0 to n key value pairs. So I can say, it's interesting, actually, this is one of their old slides that I kind of purloined for this talk. This is, anyone see the potential problem with the implementation here? Knows 3 days ago. Presumably they run a script every night to update the numbers. I'm guessing first met date would probably be a better description for that key, and probably using some kind of date time persistence instead. But basically you have these nodes and relationships. You can actually use a graph to describe the graph. So we've got a graph records data in relationships, and it also records data in nodes. You've got the points and you've got the lines between them. And relationships organize nodes, so they tell you how the nodes interact with each other, what the commonalities, what the shared interests might be. Nodes and relationships both have properties, where a property is a key value pair. And I always forget the data types, but basically a key is a string and a value is one of like 5 or 6. It's basically like Java primitives. So it can be, I think, integers, floating points, strings, the kinds of simple things you'd expect. So I would definitely recommend Neo4j has kind of been doing a lot of work in terms of making it easier to get started, and it's got to the point now where you can just download something and play with it. I would say definitely if I was to look at technologies that are out there today, the two that I would consider playing with would be Mongo and Neo4j, because they give you, what's really interesting about both of them is they don't just change the semantics of how you run your queries. They change the fundamental types of expressiveness you get and the ways you think about persisting and interacting with your data. I think Mongo in many ways is the quick win. It gives you the better immediate performance. It's not that it will necessarily perform better than Neo4j, but generally the reason people choose Mongo is for performance, simplicity, getting rid of schema updates, and easily being able to scale to multiple nodes if they need. The sweet spot for Neo4j is much more saying, what can I do with this data that I couldn't do before? How can I add more joins and more relationships and more richness and learn more from my data? And just as there's been this kind of whole wave of web technologies, and then there was a whole wave of mobile technologies that's really just taking pace now, I think there's actually going to be a whole wave beyond that of graph-based technologies where graphs will be used to disrupt the way that people operate in various industries. So up to now, I'm talking about things that are fairly well adopted. Probably the greatest adoption is obviously SQL, then maybe key value stores, then probably the document databases like Mongo, a little bit of Cassandra on the side, and then Neo4j doesn't have huge adoption, but it's growing pretty quickly. Now I want to talk about a couple of technologies that do not have yet a huge amount of adoption. And the first one is DeTomic. DeTomic's actually a really interesting system. So the backstory here, this was written by a guy called Rich Hickey. Most people know him because he was the author of Clojure, which is basically, it's a variant of Lisp that runs on the Java virtual machine. So it's kind of Lisp on the JVM, which means you actually get the power of a Lisp. It's subtly different. If you speak to somebody who programs in Racket, they say they don't like this feature or they don't think that feature was implemented well. But basically it's a Lisp that allows you to run on the JVM, which means you can finally get your code into production and not have to worry about database drivers and build systems and all this stuff that Common Lisp and all the other systems never really got right. But Rich Hickey was not done just with building a language that's actually becoming really popular. I mean, if you go to Strange Loop or Lambda Jam is the new conference in Chicago for functional programmers by the same guy, Alex Miller, who runs Strange Loop in St. Louis. Probably the majority of the programmers at those events have built something in Clojure. So it's definitely, and I'm definitely, even companies locally, companies like Intent Media, I know Kurt Schrader, the CTO over there, is definitely using Clojure. So he's built a language that's finally driving adoption of Lisp in practitioner circles, which it was pretty good. I honestly never thought that would happen, so I was impressed by that. But then he was like, well, why stop at building a language when I can also fix databases as well? And to understand this, you actually need to understand the backstory behind Clojure, which was told to me by one of the core committers, which is that it wasn't that Rich Hickey woke up one day and said, you know what the world needs is another variant of Lisp. That was actually not what happened. What happened was he says databases, variables, the way that we persist information for concurrent access, because we've got this problem, right? It used to be, we'll just make the computer's going to be twice as fast next year, so it's fine. We'll just write our code, and next year it will run fast enough. We're now kind of moving into this world where the answer isn't that the computer's going to be faster. The answer is that we'll just throw 50 or 100 or 200 computers at the problem. Unfortunately, if you have shared mutable state and locking access to variables, that becomes a problem, right? Because now you're spending all your time in deadlocks and in lock contention, so you can't just throw 100 computers at the problem, which is one of the many reasons why practitioners are now getting really excited about functional programming languages. I mean, I saw something on Hacker News just a few months ago. There are now startups using Haskell to actually build their startups. And it's who here's ever written anything in Haskell? Any a little bit? Yeah, it's not the first language you would think that small, scrappy startups would necessarily choose. And I remember I actually had a friend who was working for a hedge fund in the UK maybe 4 years ago. And he was actually building everything in Haskell. And the only problem he had, he said, well, you know, what I'm trying to do is get these kind of tools. I want to have like better database connectivity and stuff like that. But everyone in the Haskell community keeps saying, we don't want to do that, or practitioners might start using our language. So he was actually getting real pushback from the community when he was first starting to commercialize this a few years ago. Now it looks like he must have had some degree of success if startups are now using it. So this trend towards functional programming. But if one of the goals of functional programming is to kill shared mutable state, or at least to kind of make it manageable, by limiting it to certain contexts, what is a database but a huge chunk of shared mutable state that we usually have to try and reason about? And when you start writing functionally oriented programs, one of the bottlenecks becomes you still have this database that is mutable. So given that his starting point was not that he wanted to build lists, but he thought, wouldn't it be great if we could fix concurrent access to variables? And that was effectively what he did with Clojure. He created some great data structures and then needed some kind of semantics for people to actually write programs, and Lisp was there and seemed to be a reasonable fit, so that was how Clojure was born. So similarly, DeTomic was born from extending that quest for concurrent access to facts and to information and moving that to the database. And basically the way that DeTomic works is you persist facts. So think of a database with no update or delete capabilities. Now actually, and I haven't been keeping up with it for the last couple of months, I know that one issue, I think they're going to figure out a way to have a kind of delete this if you really, really, really want to. Because one of the issues you run into is with things like EU data protection laws. Having a data store where you can genuinely, absolutely never remove facts is actually problematic from a legal perspective, because if one fact is my email address and I say I want to be removed from your list, they actually need to be able to destroy that data from what I understand. So they're still working out some of those issues. But conceptually what you have is an immutable data store. And so it has a number of really interesting properties. One of them is that any given query pointing to any given point in time will always return the same result so that you can consistently reason about it. And then what they've also done is they've made an interesting kind of structural change, which is they've decoupled the transactors, the stuff that you run queries on, from the places that you actually store the data, so that you may not use the same nodes for querying information that you actually use for ensuring that that information is persisted on disk for long periods of time. And that actually seems to be a trend that I'm seeing, because in NuoDB, which we'll come to in a moment, they also have that distinction between the two different types of nodes. The nodes that are used for long-term guaranteed persistence of information, and the nodes that are simply used for running the queries, often within memory access to enough information to make those queries run. It's definitely early days. There is now a version of DeTomic that you can access with fairly easily from any language, but historically, again, it's for the JVM. It was specifically, the starting point was writing apps in Clojure. DeTomic was a great back end. I'm now seeing Java and Groovy and JRuby developers work with it, and it's just starting to get a little bit of interest in broader languages communities like the Ruby and the Python world. But it's still very Java, JVM focused. But it's a really interesting solution, and I would thoroughly recommend taking a little bit of time to look into what it can do. And then to kind of bring it back round to the power of SQL, as we said earlier, SQL's kind of cool. And the problem with all of these other solutions is the cognitive load that they impose in terms of learning. Because now you've got to start understanding data modeling using a graph, or data modeling using documents, and figuring out, I mean, just even the simple stuff. There are patterns you use with Mongo, for example, where let's say that I wanted to get a post with a range of comments. What I'm actually going to do, trying to think the best example, perfect. Comments and users. So remember we had that use case earlier where with each comment we had the user and we'd embedded their name. but now we found we need the number of comments they've done. So what we're going to do is we're probably going to now pull the names out from those comments documents, and we're going to have the user documents. But the problem is we get this n+1 query problem, right? I'm going to run a query which says, give me all the comments for this post. And then for each one of those comments, get me user 43, get me user 107, get me user 16, go and get those users. So if I have 20 comments, I'm going to run 21 queries. One to get the 20 comments, and then one for each of those 20 queries. Well, the way you solve that, obviously, in SQL, you'd solve it with a join. We don't have that available in Mongo. So what you would do in Mongo is instead, you actually do an in-query, which is something you'd really never think to do at scale in a relational database. And literally, you write your own little bit of code. You actually are writing your own join. You write your own little bit of code that says, OK, I'm just going to catch all of the IDs for all of the users, and then I'm going to basically select from the users collection where ID is in this comma delimited list of IDs. And it just turns out that with Mongo, those kind of inquiries can be performed up to thousands of elements within them. It can still be a performant query, which probably wouldn't be true in most relational systems. So performance-wise, it's absolutely fine. But what you're forcing yourself to do is it feels like you're rewriting joins, that you're taking care of something that the database used to take care of in the past. And I think the same is true with things like multi-version concurrency control. When you've got the benefit of being able to just write to all of these different nodes, the downside is now you need to deal with optimistic locking failures, right? The times where you wrote two different things to two different nodes, and it turns out there was actually a real conflict there. So it feels like all of these things are, even though they're taking us forwards in terms of performance and capabilities, in some ways they're kind of taking us backwards, because now we're having to do more of the stuff that we used to get for free from MySQL. And so here comes NuoDB, one of a number. It's not the only player in this space, but it's the one I've got the most familiarity with, which is basically saying, wouldn't it be great? The only reason you even cared about all of these NoSQL data stores, except maybe for graph databases that give you totally different capabilities, all the other stuff, it was just because you wanted to be able to spin up 20 different nodes without your sysadmin deciding to commit suicide or quit and go surfing instead. You wanted to have an easy way to spin up multiple nodes. Well, wouldn't it be great if you could leave your programmers still writing ANSI style, like fairly compliant SQL, but yet still have the ability to spin up multiple nodes? And that is basically what NuoDB is designed to support. So it is a relational database, they say designed of and designed for the cloud. I did actually an interview with Seth, who was their CTO for InfoQ a few weeks ago. Tomorrow I will actually tweet up at Peter Bell, is my Twitter handle, and I'll tweet up a couple of links for anyone who's interested. But basically what NuoDB does is it allows you to get the scalability and capabilities of a NoSQL data store while still writing SQL. So it's been kind of a romp through the database landscape. We started with, obviously, that SQL rocked, and then starting to look at NoSQL stores, the aggregate stores, the Redises, and the other key value stores out there. Things like Cassandra, which are great for high value and for high quantities of data, especially for write scalability. And things like MongoDB. And one of the things I love about Mongo is, unlike something like Cassandra, where it can take a week to get things configured, you can literally get started with Mongo in 20 minutes. So it really is a nice data store just to use. There's no reason not to use it on a small volume project, if only to learn the strengths and weaknesses and the approaches you need from a data modeling perspective. Neo4j for me is in some ways the most interesting, because it's at this sweet spot between it's just getting enough adoption, but it's radically different in terms of the capabilities that it gives you. It allows you to create different kinds of solutions and get a lot more richness from your data sets than you can with traditional relational or other NoSQL stores. DeTomic and NuoDB are really interesting. DeTomic is interesting just because of this idea of an immutable data store. And I still really haven't had the time to dig in with either of these to get a lot of hands-on experience. But it seems to me like it's showing us, there was another presentation at Strange Loop last year from the Twitter team, and it sounds like they've built something that one part of their system feels and looks very much like DeTomic in terms of being an immutable data store. So I think something we're going to increasingly see as the world moves to functional programming languages is a trend towards immutable data stores. And we're going to have to see what those implications might be. And then finally, I think the idea of NuoDB is a fascinating promise. And they only launched formally in the last 2-3 months, I think. But potentially, if you're at that point where you're like, I really hate the idea of giving up SQL, but we have these huge performance issues we need to deal with, NuoDB is the kind of technology you should look at, because you may be able to keep the query language and keep the code and solve your scaling problem separately. So we're supposed to be done about 5:15, so it gives us just a few minutes for questions. Any questions?
Yeah, as you saw, like Neo4j is really good for handling lots of relationships and complex, especially complex relationships between nodes. But what about scalability? Like, and does it work in distributed environment?
So that's a great question. The question is, Neo4j is great. It gives you all this rich information. You can run queries you otherwise couldn't. But what happens, how does it work in terms of scalability or distributed environment where you have multiple nodes? That's still a challenge. The first thing I'd say is you need to look at scalability from a realistic perspective. If you've got only a few billion nodes, if you've only got a few billion data points, which for a lot of us is more data than we'll ever come across, in 20 projects, then a single node or 2 nodes with master-master replication is fine with Neo4j, so you're set. However, Neo4j is not competing with Cassandra. It is not designed, if you've got gigabytes or petabytes of data being written every few days, you're not going to use Neo4j for that. In fact, what you'll probably do is you'll probably run it through Hadoop, persist that in Cassandra, and then you'll have probably some kind of message queue somewhere or some kind of job that takes a subset of that pre-formatted, pre-filtered data and drops that into a graph so that you can reason more richly about the things you care about. So often Neo4j will be used in an environment where there's huge quantities of data, but just not all of that data will go into Neo4j, and that's the way to solve that. In terms of a distributed environment, there's no, even from a theoretical perspective, there's no easy way to say, how do you shard a graph? Traditionally, what you do when you have a large amount of data is you shard it. So for example, MongoDB has this wonderful thing called auto-sharding. You set a shard key, you tell it which of the keys for a given collection. Collection's kind of like a table in a relational database. So let's say I've got a collection of users. This is where my users are. And I have 2 billion users. It's too much to fit on one machine effectively. I'll give it a shard key of, I don't know, maybe email address, maybe the state they live in, maybe the country they're from. There's lots of shard keys with strengths and weaknesses. And then what it will do is it will intelligently, and then I can spin up, say, 3 sets of nodes. And what it will do is it will put some of the users, it will intelligently shard based on, say, their email address to put the right users on the right machines. So sharding is something you can do in most systems. It's difficult. It's fairly straightforward in something like Mongo, because you just put different documents in different places. It's a little more difficult with relational databases, because you have to deal with the relationships and if they go cross joins. It's incredibly difficult with a graph. How do you shard a graph? I mean, you've just got nodes and lines. I mean, the kinds of approaches to that you'd probably take would be a probabilistic one based upon common queries and commonly traversed spaces, right? It would be plausible for you to write some code that would say, show me all the relationships, come up with some of the kinds of ways I might be able to cut this graph, and then look at selecting for the least traversed relationships, the least frequently traversed relationships, and then I would shard based on that. So you could take this kind of probabilistic approach based upon your actual query patterns, but nobody's like, there's, to my knowledge, I don't think even, in computer science, I don't think there's definitive, like, here's the PhD study on how to shard a graph. It's still a fundamentally hard problem to solve, so they haven't solved that, although they are working on it. Yes?
This was great, first of all, so thank you so much for that. You mentioned that there's no integrity checking on a lot of those. So Could you expand this? Is there, it seems to me a little bit like a move from strongly typed language to weakly typed language. So does it come with a lot more like testing on the database field? Do you see that a lot more test-driven design? In addition, is it flexible enough to be used, like if your data model is not ready yet, like if you rapidly integrate? And then the integration with like things like Django or Rails, is it kind of on the road, or is it not at all there yet?
Got it. So a few questions there. So you know what, I'm going to start at the top, and then if I forget some, you're going to have to remind me. The first question is around integrity checking, and I want to break that out into two distinct things that are worth being aware of. One type of integrity checking is, did that actually get saved? And it's possible in databases like Mongo, for example, to fire and forget your queries, to basically say, save that, don't bother telling me if it worked. This is great from a performance perspective, but you're immediately losing guaranteed durability. If somebody pulls the plug on that server at the very moment you send that, you don't get told for a period of, you don't find out for a while that all this stuff you're blithely sending to the database server isn't actually getting saved to disk. However, most of the time, by default these days, even in single node mode, Mongo will give you guaranteed durability. So most NoSQL data stores will give you guaranteed durability unless some of them give you this extra performance tuning option to switch that off. The next level of integrity checking, which is perhaps the one you were more focused on, is schemas. And schemas can indeed, I actually use that example pretty often, which is comparing schema versus schemaless database to strongly versus dynamically typed languages. So it's this idea that you're getting these extra checks, right? The nice thing is that there are certain mistakes you can't make in Java or C# that you could very easily make in Ruby or Python, because if you mistype a variable name, it's not going to compile. It's going to say, hey, I'm sorry that you mistyped. It doesn't know what you should have typed, but it knows it shouldn't have been that. And you get auto-completion in your IDEs in IntelliJ or Eclipse or whatever you're working with. So it's similar. You're in a similar situation that you're putting that responsibility. When you give up a strongly typed language or statically typed language and you move to something like Python or Ruby, what you're doing is you're giving up that guarantee that the compiler will do some checking, and you have to replace that typically with test-driven development, or at least with good unit test coverage. And so similarly, when you move from the relational database, where at least you can guarantee that every user has a middle name and they all have a social security number, because you set those integrity constraints, and you can set rules to make sure that you can't delete the last address for a user, because every user needs to have an address or whatever that is. You lose all of those integrity constraints and you need to put them into the application, which says a few things. First thing it says is often you want to have a single application speaking to these schemaless data stores. Because one of the things you can kind of sort of get away with, especially in an enterprise environment, is here's the database and we've got these 20 different applications that speak to it. And at least we get a base level of integrity checking from the validations we put right into the database. So one of the practical implications is that, firstly, most companies using these are using them just as a store for a single database, for a single application. But yeah, one of the things you have to generally do is have one application that is the front for this database and that implements all of your data integrity checks. And then if you want other applications to have access to that data, they should probably call through a RESTful API against that application rather than calling directly to your Mongo or Redis database. And yes, so the final part of this is, yes, you kind of need to do effectively unit testing for your database, where what you actually want to do is write more tests which will validate that you often write test queries basically that will run on some kind of basis to ensure that, for example, do all my users have a middle name? Do they all have a social security number? Is it well formed? And have those scripts running and then reporting back to you if you get malformed data. Not everyone's doing that, but if they don't do it, then eventually they're going to get into trouble. And it's actually 20 past now. Is there one other question? Yes?
You prophesied disruption. Do you have any visions of where that disruption is going to come?
So prophecies, any predictions as to where the disruption will come from?
Yes.
I certainly think that we're going to see two major changes over the next few years. One is I believe that we're going to see a huge growth in the usage of graph databases for learning more from the data that we already have. And the other thing is I think we're going to see a huge trend towards immutable databases to supplement and support more and more programming using functional languages. Great. Well, I'll be around for a few minutes if anyone has questions. Otherwise, thank you all very much for coming out.